Hello and welcome back. We're now going to see if this series converges or diverges. So with the over n part, I'm pretty familiar with that because I know that the series 1 over n diverges. But with the e thing on the top, I'm not sure what to do. So what I'm going to do now is just take this e thing and put it in the calculator and see what is that. So for example, if you have e to the 1 divided by 2, all right, that's not a very big number. What if you have the e in 1 divided by 10? It's actually getting smaller, it's getting close to 1. It is going to be, so it looks like the e thing on the top is getting close to 1. So as n goes to infinity, the top is basically becoming a 1. So if this is basically becoming a 1, then my first guess of the 1 over n is actually going to pay off. I think this diverges, and I think we should use 1 over n to prove it. So if we use the direct comparison test, then just divide the two, so you'd have e to the 1 over n, which is divided by an n, and we've got the limit as n goes to infinity, and then divide by this 1 over n, and of course dividing by a fraction means that we invert and multiply. And then take the limit, and as long as we get a number that is bigger than 0, we're in business, and that will prove that it diverges. So is this going to be an actual limit? And if so, what is it going to be? Well, as you can see, these n's can cancel. Didn't know I had the eraser. Those n's can cancel. And so basically it is, what is the limit as n goes to infinity of e to the 1 over n? And I think I was just seeing that on the calculator. As the n gets bigger and bigger, these answers over here are getting closer and closer to 1. So why is that? So if n is going to infinity, then this is becoming 1 over infinity, and 1 over infinity becomes a 0, and then e to the 0 is equal to 1. And then that's it. The direct comparison test says if you get a number that is bigger than 0, not equal to 0, so this is bigger than or equal to 0, therefore it diverges.